Welcome to T2, Day 7 of Honors Precalculus. We're going to continue with our journey through trig. So let's warm up by verifying some trig equalities. Remember that when you're dealing with these, you need to pick one side and turn it into the other. So your choices are left to right or right to left. And one thing from the last video you might remember is that it's easier to go bigger to smaller, and also if you have a plus, start on that side. So in this case, what we're going to do, can't do anything with sine, so it's just sine x over 1. Cotangent is defined as cosine x over sine of x, and cosine right there is just cosine x over 1. So what do you do in this case? Well, you end up with sine x over 1 plus cosine squared x over sine of x. And to add fractions, you need a common denominator. So we're going to multiply this one by sine of x over sine of x, because that's just a fancy form of 1. And that makes the fraction on the left sine squared x over sine of x, and you're adding to it cosine squared x over sine of x, which is going to be equal to sine x squared plus cosine squared x all over. And remember, you should say it as sine squared x. And this is over sine of x. This right here is the Babylonian identity, so it's going to be 1 over sine of x. And by definition, 1 over sine of x is cosecant x, which is exactly what we wanted to show. Over here, you have to be careful, and you need to remember from a couple videos ago that this is factorable. And the way you can kind of see it is, it's the same as a squared plus 2a plus 1 if a was equal to sine of x. So this actually factors into sine of x plus 1 times sine of x plus 1, same denominator. So this cosine is there, and that yellow numerator factors as such. Now what happens is cosine, you need to remember cosine, sine squared plus cosine squared x is equal to 1. So that means that cosine squared x is equal to 1 minus sine squared x. So you can take that and plug it in there. What that leaves you with is the same numerator, so sine of x plus 1 times sine of x plus 1. You can write it squared if you want to, but keeping it separate can help, over 1 minus sine squared x. And you might remember that this is the difference of squares, so you can factor it into, again, same numerator. And I know it seems like a drag to write it again, but it only takes a little bit. And you have a lot of space, so space it out. It's the difference of squared because it's 1 squared. So it's 1 minus sine of x times 1 plus sine of x. Well, guess what? These are the same, so you can cancel them, and you end up with sine of x plus 1 over 1 minus sine of x. And you go back up and you look, is that the same thing? Oh, it is. It is the same. So we are done. It worked. So in this case, you need to remember two things. You have to factor the numerator, and that cosine squared is 1 minus sine squared. So just as a warm-up for what's to come next, we need to remember how to solve something that looks like this. And what we're going to do first is set it equal to 0. So subtract 6. So 2a squared minus a minus 6 is equal to 0. And you need to remember how to factor when the leading coefficient is not 1. Well, it means you're going to have 2a, and it equals not a, it equals 0. And you need two numbers that multiply together to get negative 6. So you can just test things, and if you test it out, you'll note that this will work. And you test it by foiling this out and seeing if the middle term comes out to negative a. In this case, it does. Keep track of what you test. Two things multiplied together, green thing and the blue thing. So what that means is 2a plus 3 must equal 0, or a minus 2 must equal 0. So 2a equals negative 3, meaning a equals negative 3 halves, or a is equal to 2. There are two answers to this. This is important because we're going to do it with trig functions. So this one says solve this trig equation. Remember, we're not verifying, so we can use both sides at the same time. So we're solving this. The first thing we're going to do is we're going to take sine squared t, and again, we know that sine squared t plus cosine squared t is equal to 1. So sine squared t is equal to 1 minus cosine squared of t. So we're going to take that and plug it in. So we end up with 3 times 1 minus cosine squared t, and keep the same thing on the right-hand side, 5 cosine t. And the reason we did that is we wanted to try to get the same trig function. We now distribute this 3, and you end up with 3 minus 3 cosine squared t equals 5 minus 5 cosine t. Gets a little messy, but similar to what we did above, we're going to put everything on one side. We're going to take this side and put it over there. So subtract 3 and add 3 cosine. squared. So we get 0 is equal to 5 minus 5 cosine t. Then we're subtracting 3 and adding 3 cosine squared t. So what we end up with is you have a 5 right there and a negative 3 there. So these two come together to get 2. So I'm going to put this in order of power. So it's 0 equals 3 cosine squared t, that's this term, minus 5 cosine t plus 2. It's all in cosine, so how does this help? Well, you have a squared, and then you have it to the first power here. So what you can say, if you want to see this, let a equal cosine t. What you're really looking at is 0 equals 3a squared minus 5a plus 2. And this is nicely factorable. This factors into 3a minus 2 times a minus 1. A, though, equals cosine t. So what you actually have is 0 equals 3a, not instead of a, you have, cosine t minus 2, and then you have cosine t minus 1, and this equals 0. So what that means is you have two things, the green thing and you have the blue thing. For them to multiply together to be 0, at least one of them has to be 0. So 3 cosine t minus 2 has to be 0, or the other one is cosine t minus 1 has to be 0. You have to be super careful about this. So this means that cosine t is equal to 1. So in this case, t is equal to cosine inverse of 1. And when you do cosine inverse of 1, the cosine of what is 1? Well, that's 0. So that's 0 plus 2 pi n. And remember, for cosine, you also do the negative of it. So the other value would be t is equal to negative 0 plus 2 pi n. Well, negative 0 and positive 0 are the same thing. So in this case, there's one answer, which is just 2 pi n. Over here, you end up with 3 cosine t is equal to 2. So cosine t is equal to 2/3. So t is equal to cosine inverse of 2/3. In this case, when you do it, you end up with your first t value, which is the cosine inverse of that, which is going to be 0.841 plus 2 pi n. But then you have to do your second one. And remember, your second one is going to be pi minus, there's the opposite, that's for sine. The opposite of this. So the other one is going to be negative 0.841 plus 2 pi n. So how many answers do you actually have? You have one of them, two of them, because there's 2 from here, and there's only 1 here because 0 and negative 0 are the same number. So there's 1 answer, 2 answers, and 3 answers. Again, it just takes practice. The key on this one was you're solving this, you're not verifying it, so you can use both sides. This one's pretty tricky. It's going to take practice. So that one was in radians. Let's keep on going here and work on this next one right here, which is solving this one for radians. You'll notice that this is in cosine and this is in sine. So similarly, we're going to need to put it into terms of one trig function. Well, cosine squared t is equal to 1 minus sine squared t. It's very similar to the last question. So we end up with 6 times 1 minus sine squared t is equal to sine t plus 5. So you get 6 minus 6 sine squared t is equal to sine t plus 5. Put everything on one side. So 0 is equal to, in this case, 6 sine squared t plus sine t minus 1, because 5 minus 6 is negative 1. And then what does that factor into? Well, if you play around with it, you end up with 3 sine t minus 1 times 2 sine t plus 1. And if you want to figure that out, you can make it 6a squared plus a minus 1, and it factors into that, where a is equal to sine t. So what that means in this case is that 3 sine t minus 1 is equal to 0, or 2 sine t plus 1 is equal to 0. So 3 sine t is equal to 1, sine of t is equal to 1/3. So now what you have to do is do the inverse. So you know that t is equal to sine inverse of 1/3. That's the first t value, and it's plus 2 pi k. But the second one, when you do that out, you get a decimal. So you get t1 is equal to sine inverse of 1/3 is 0.340 plus 2 pi k. And the second one, remember, is pi minus 0.340. So when you do pi minus that, you end up with 2.802. So our second t-value is going to be 2.802 plus 2 pi k. So we have one answer and two answers. But now we need to do the same thing right here. We need to do the same thing right there. So what we're going to do is we end up with 2 sine t, partition that off, is equal to -1, moving that 1 over. So sine of t is equal to -1/2 right there. This is actually a trig value you know. T is equal to the sine inverse of -1/2. Remember, sine is the y value. So when you do that, it's actually going to be your first t value is going to be pi over 6. And you add 2 pi n to that. And then to get the second one, remember, it's pi minus this. So it's minus pi over 6. Minus pi over 6. So that value, you subtract it from pi to get the second t value on this side. So it's going to be 7 pi over 6 plus 2 pi k. So we have two more answers. So in this case, this one has 4 answers inside 0 to 2 pi. 4 answers. It takes practice. It takes practice.